Okay, so if you've ever sat in a technical interview, you probably know that feeling. That cold sweat when the question drops. So, what's the difference between an interface and an abstract class? It feels like it should be simple, but it's a classic for a reason. Today, we're going to crack that code and figure out what interviewers really want to hear.
This quote, it comes straight from a developer on Stack Overflow, and it just perfectly captures that frustration, right? You list off all the technical details you know, single versus multiple inheritance, implemented methods, but you can feel it. The interviewer is just waiting for some secret password you don't have. So what is that missing piece?
And this is one of those riddles that totally stumped that developer. I mean, on the surface, they seem almost identical in this situation, don't they? But the difference isn't just about syntax. It's a really fundamental concept in design. And we're about to uncover it. But first things first, let's get the basics on the table.
Right. Before we get into all the deep design philosophy, we've got to cover the standard technical facts. Think of this as the baseline knowledge. You know, the price of admission to even have this conversation.
Okay, so let's do a quick rundown. An abstract class, it can have variables, which is huge because that means it can hold state. It can also have concrete methods, with full implementations. A key rule, though, is that a class can only inherit from one abstract class. An interface, on the other hand, well, traditionally it's just a contract of methods, a promise. And because it's just a contract, a class can implement multiple interfaces. That's a major structural difference. So this is the what, but it's not the why. And this is where we have our first big breakthrough. See, the choice between an abstract class and an interface isn't just about what the compiler lets you do. It's about the kind of relationship you're trying to model in your software. Are you building a family tree, or are you signing a contract? Here's a really fantastic analogy to make this all click. Let's think of pilot as an abstract class. You can't just be a generic pilot, right? You have to be a specific type of pilot. So a C-141 pilot is a concrete class that inherits from that pilot abstract class. But that same pilot could also be given an extra duty, like safety officer. Now that's not part of their core identity as a pilot, it's a role they can perform. That role, that's the interface I-Safety Officer.
This brings us right to the heart of it, the core conceptual difference. An abstract class defines an is-a relationship. A C-141 pilot is a pilot. It's fundamental to its identity, its place in the whole hierarchy. An interface, though, that defines a can-do relationship. The pilot can do the duties of a safety officer, but you know what? So could a mechanic or an administrator. It's a capability, a contract for a behavior that isn't tied to one single family tree. So this whole is-a versus can-do thing, it moves us way beyond simple language rules and into the world of system design. Really all comes down to your intent. What are you actually trying to achieve with your code structure?
This quote just nails it. It separates the two ideas so perfectly. You use an abstract class to model the absolute essence of a thing, like an animal or a vehicle, giving it some core identity and maybe some shared functionality. But you use an interface to define a behavior or a capability, like being iClonable or iDisposable, that all sorts of unrelated things can have.
Now, this design choice has some seriously crucial real-world consequences, especially when it comes to versioning. Think about it. If you release an interface and later you decide to add a new method to it, you've just created a breaking change. Every single class that implements that interface is now broken. It won't compile until they add the new method. But with an abstract class, you can add a new, fully implemented method, and all the classes that inherit from it just get that new functionality for free. It makes abstract classes way more forgiving to evolve over time.
All right, so now that we're armed with this much deeper understanding of intent, of relationships, of practical impact, let's circle back and tackle those tricky interview riddles with some real confidence.
Okay, here's that second riddle. The developer who originally posted this was correct. He kept insisting that in most languages, you can't have a true instance variable in an interface. But that's not what the interviewer was testing. They were digging for a much deeper concept.
The interviewer was using this question to ask about state. That's the secret. An abstract class can have member variables. It can define the core data and identity of an object. It's a template for a thing that has properties. An interface, though, is a contract for behavior, and it's completely separate from the state of the object that implements it. That's the high-level answer they were really looking for.
And now, let's go back to that first riddle. We know the simple answer is about single versus multiple inheritance. But we can do so much better now. What's the real, fundamental difference, even when they look syntactically the same in this weird edge case?
The difference is hierarchy. That's the key. When you inherit from that empty abstract class, you are making a permanent, defining choice. Your class is a type of that parent. You are locking it into a single inheritance tree, and you only get to do that once. But when you implement an interface, you're just saying your class can do this thing. It can sign multiple contracts, adopt all sorts of capabilities, without ever being locked into a single lineage.
So let's boil this all down. Here are the key takeaways. You use an abstract class for an is-a relationship. That's when you're modeling a family of objects that share an identity and maybe some code. You use an interface for a can-do relationship, for when you want to define a capability that can be picked up by lots of unrelated classes. And always remember the practical impact. Changing an abstract class is usually way easier than changing a published interface. The next time you have to make this choice, don't just ask abstract class or interface. Ask yourself this instead. Am I defining what something is, or am I defining what something does? If you can answer that question, you'll make the right design choice every single time.